Hey guys, this is part 7 of the aspirin to fluorescein synthesis. In the last video, we isolated 3-aminophenol hydrochloride. Today we will convert that into resorcinol, which is the penultimate step in the synthesis. To do this, we will perform a reaction known as a diazotization, followed by a quick hydrolysis. Normally, the first step in a diazotization is to dissolve the aromatic amine in a large excess of hydrochloric acid to form the anilinium salt, and then carrying on with the reaction. But by a lucky coincidence, in the last video, to purify the aminophenol, we converted it to the aminophenol hydrochloride salt already. This means that in the reaction, we will use 1 molar ratio of hydrochloric acid less than normally needed, since the amine is already protonated. Alright, so let's begin. First I dissolve 0.16 grams of sodium nitrite in 2 ml of water, and set the solution aside for later. Then I prepare a tiny round bottom flask and add 2 ml of 10% hydrochloric acid to it, followed by the 0.24 grams of 3-aminophenol hydrochloride from the last episode. Once dissolved, I set up an ice bath and thermometer and cool down the solution to between 0 and 5 degrees Celsius. The sodium nitrate solution from earlier is added dropwise to the cold acid solution using a pipette. I allow the mixture to stir for 10 minutes in the ice bath. Here's what's happening. Firstly, the sodium nitrite reacts with hydrochloric acid to form nitrous acid. Nitrous acid is then protonated by the hydrochloric acid, causing this part of the molecule to leave as water, leaving behind the electrophile known as the nitrosonium ion. The lone pair on the nitrogen of the amine then attacks the electrophile, forming this very unstable N-nitrosoammonium ion. Then a water molecule strips the proton from this intermediate, leaving the N-nitrosamine, which then tautomerizes to form a diazo hydroxide. This diazo hydroxide is then protonated, causing it to lose a water unit, leaving the diazonium chloride salt. Once the 10 minutes are up, I remove the ice bath and add 25 ml of water to the solution and start heating the water bath to 40 C. The combination of the gentle heating and the water we added to the solution causes the unstable diazonium salt to hydrolyze, releasing nitrogen gas which floats away. The nitrogen is replaced with the hydroxyl from water, forming resorcinol. The solution becomes much brighter in color during this step, and I don't exactly know why. Once no more nitrogen gas is observed being released, which took around 15 minutes, I decant the solution into a beaker. We now need to extract the resorcinol from the mixture. The first thing I do is add some dilute sodium bicarbonate solution to neutralize the remaining hydrochloric acid and form its salt. This also causes any unreacted aminophenol to fully convert to its free base form. I then move the solution to a separatory funnel and wash it 3 times with 10 ml of DCM. Even though resorcinol is an organic compound, it is extremely soluble in water due to its multiple hydroxyl groups, which form strong hydrogen bonds with water, making it not very soluble in chlorinated solvents like DCM. This washing effectively removes any unreacted aminophenol, which does dissolve in the dichloromethane, while leaving the highly polar resorcinol in the water layer. The now cleaner aqueous layer is added to a beaker. Now, the only impurity present is all the sodium chloride salt formed in the reaction. This is easy to separate, and the first thing to do is heat up the solution and boil off all the water. Resorcinol is not very volatile and remains as a solid in the beaker, mixed up with the salt. Once I'm left with a dry solid, I add 20 ml of isopropanol and heat it up to a boil. The alcohol selectively dissolves the resorcinol while leaving the salt undissolved. The solution is then filtered to remove the sodium chloride. I evaporate off 95% of the isopropanol to leave a very concentrated solution. I then again get out my DCM and add 5 ml of it as an anti-solvent, and allow the solution to cool down to negative 20 C in the freezer. This causes the resorcinol to crystallize out of solution, and I then filter it off. I also recrystallize the product from toluene, but it turns out I forgot to start recording for that part. Anyways, I ended up with 0.15 grams, or 83% yield, of slightly discolored resorcinol of quite decent purity. The toluene crystallization managed to remove the precipitated brown colored impurity, allowing me to filter it off before recrystallizing, which greatly helped purify the product and makes it kinda sad that I didn't record it. Anyways, in the next and last episode, we will make the final fluorescein product that we have been waiting for the last 4 months. See you guys soon.